Hi guys, let's talk about the difference in difference method. This is a popular method to find out whether there is some kind of causation. Let's start with a story. Say that we visit some very poor places in Chiang Mai, okay, I'll call it CM, which is a big city in Thailand. And in 2005, say, we went into the slums and did a test and found out that the average score after testing a number of students was something as low as 20. So what we decided to do was to provide free lunch. You can imagine good reasons why we would want to provide free lunch to students that live in the poor rural areas in Chiang Mai. We believe that, for example, better nutrition would contribute to better health, and if they have better health, they can perform better in school, and so on. So after a few years, in 2008, we did a test, and we found that perhaps the score went up to 90. So here's a question. Would you say that this increase of 70 points is due to free lunch? Of course, difficult to establish this, because there could be, number one, many other reasons why students' performance has improved. But more importantly, we do not know the counterfactual. If you recall, the fundamental law of causal inference means that we cannot observe the counterfactual. That is, we do not know the score of Chiang Mai students in the rural areas that were tested if they did not have free lunch. That is not observable because we are observing here the results of students' score after they received the free lunch or the treatment. So how do we sort this out? So the difference in difference method requires you to have, of course, a control group. So say as a control group somewhere in another big city in Thailand called Bangkok, say we also conducted a test in a very similar rural area, but this time in Bangkok, in 2005, and the average score we got, say, was 30. And we did a post-test in 2008, and we found the average score to be 70. So Bangkok would be what you call the control group, and Chiang Mai is the treatment group. So now you notice here that in fact Bangkok, which did not receive free lunch, so there was no treatment in Bangkok, the scores actually improved by 40. Whereas in Chiang Mai, the scores had improved by 70. So what we can say from this result is that the actual effect of free lunch would be 70 minus 40, which is 30. So this is what we will call the ATE, or average treatment effect. So one more time. So what we find is 70 is the difference between 90 and 20 in Chiang Mai, and 40 is the difference or the improvement in the scores in Bangkok from 30 to 70. So there's a difference and there's a difference, and we're differencing the difference. So we have this method called difference in difference. And we have found what we're looking for, which is the average treatment effect. That's the effect of free lunch. Another way to see this very quickly is as follows. So we can put here, say, what we call the pre-test period, 2005, and the post-test, 2008. You will notice that in Chiang Mai starts at around 20, while in Bangkok the score was 30 in 2005. In Bangkok, the score went up to 70, so somewhere up here. But in Chiang Mai, the score went up to 90, which is somewhere here. Now, what to notice is that just imagine that if Chiang Mai did not get the free lunch, what would be their score in 2008? So it would have gone up by 40, so would be somewhere here at 60. So basically, we have constructed the counterfactual. So we notice that the score actually went up to 90 due to free lunch. So the difference here is ATE, which is equal to 30. Good. Let's look at some real data. Now say that this is the real data. So we have individual scores for 10 students, and you can verify these averages that we have here are actually from this raw data. For example, let's say you'll notice that 2005 Bangkok, so that's Ploy's score. And then we have 2005 again Bangkok, so we have another score here. 2005, another Bangkok here, that's 30 and no more. So the score is 30 plus 20 plus 40. So this would be 30 plus 20 plus 40 divided by 3. So which should give us 90 divided by 3, which is 30. So we can do the same. So all these scores are actually from the raw data here. So let's use this raw data to find the ATE. Don't forget, the average treatment effect we got was 30 using regression. That's what I'm going to show you now. So here's the data again. As to find the average treatment effect, what we can do is to run a regression which looks like this. So we have score as the independent variable, then the constant plus, let's call it beta 1. We can put in here what we call the treatment group, then plus beta 2, we'll call it the post-year period, plus beta 3 is called an interaction variable. So we're going to multiply treatment and post. And when we run this regression, feed this into GRETL, for example, get our coefficients, and what we have is to look at this, which will give us the average treatment effect of 30. That's what we will do. Okay, what's TR? TR is a dummy variable that takes 1, 0, depending whether we're talking about the treatment group or the control group. The treatment group means that it will take value 1 for Chiang Mai and 0 for Bangkok. From this city, we have to create another variable. We'll call it TR. So Bangkok will be 0, Chiang Mai will be 1, and then 0, and then 1, and so on and so forth. We're going to construct another variable here called TR. Then we're going to construct also another variable called post, which is 1 for the post year, so 2008, and 0 if it is 2005. So we create another variable called post from this variable here. And for 2005, it will be 0. 2008 will be 1. This will be 0. This will be 1, and so on. And then lastly, we're going to create what we call an interaction variable, which is nothing more but the multiplication of these two. Let's call it TR times post. So we're going to do 0 times 0 gives us 0. 1 times 1 is 1, 0 times 0, etc. And we will construct these variables. Then we will run this regression as you see it here. Shall we try that in GRETL? Okay, let's take this data into GRETL. I've put them into Excel. Here it is, the same data. You can do this easily. And we can bring this into GRETL as follows. So I'll show you how to do that. To bring the data, here's my Excel file that contains the data. Just drag and drop. So it will ask you whether you start importing sheet 1 from column 1, row 1. Go OK. And there you have everything here. It asks you whether you want to interpret this as a time series or panel. Say no, and we are done. Let's take a look. Select all these, enter, and there's my data. So it's exactly like the one we have up here. Okay, so we need now to make dummies. So city, we should make another variable called, say, TR or treatment, where it's going to be 0 for Bangkok and 1 for Chiang Mai, etc. And we have to create another variable called post, which says 2005 will be changed to 0 and 2008 changed to 1, and so on, and create the interaction variable. So let me show you how to do that. So to make the dummy variables, go to city, say add and dummies for discrete variable, encode everything. Say OK, and there you have two, DCT1 and DCT2. So this is a dummy for Chiang Mai, the treated city. So let me rename this. So right click, say edit attributes, and let's call this, as we did up here, TR. There we go. Going to do the same for year. We want to dummy all the years so that 2005 is equal to 0 and 2008 is equal to 1. So we can go to add again dummies, or we can just right click on this variable and there's a dummy file, which is the same thing. And let's just do for all of them, though we could have selected one particular value. So this is going to be post. So let's right click, change this to post up here. So POST. There we go. So we have now the treatment dummy and the post-test dummy. So let's create the last one, which is the interaction variable. So you go to add, define new variable, and here let's call it as we did up there, TR with a big X and POST. This is equal to the treatment TR times post POST. So essentially we are multiplying this variable number 6 and number 8. Let's take a look now. So let's open up the score, the TR dummy, the post dummy, and the interaction. Okay, using your control button. So that's what we have now here. Find that, for example, score 40 corresponds to that one, 40 there, and Bangkok is 0, year is 2005, so 0 that we have. So that's the first line, and if you multiply 0 times 0, you get this one, and so on and forth. The second line will correspond to Somchai, the third line will correspond to golf, etc. So now we are ready to run the regression. That this is the regression. So all we have to do is go to GRETL. So regression model is down here. So all we have to do is go model, OLS. So let's select the score is the dependent variable. Then you have TR. There you go. Post and the interaction variable. And all you have to do is observe the coefficient on the interaction variable. So, and remember last time, what did we get? The ATE as a value of 30. So go OK, and there we have it, 30. So we have found the average treatment effect. So in this video, I've shown you how to find the ATE by simply looking at averages and comparing the difference in the treatment group and the difference in the control group and subtracting the two, so 70 minus 40, to get the average treatment effect of 30, right? But we can use regression if we have the raw data as it is. Then we can dummify the variables of interest, create an interaction variable, and run the regression, and we get the ATE. Now the advantage of using regression in this context is twofold. First, imagine trying to get the average of each of these values if we have very many observations, and trying to match the average and make it into a kind of table like this. That would take quite a long time. Of course, the computer can help you. But more importantly, suppose you have some more information, for example, the actual incomes of individual subjects. Then you can actually add that into the regression. So let's call it beta 4, okay, income. And this can act as a control. Remember that you can only believe this value you get if there is no confounding. But most likely income could be a confounder, meaning that it is related to students, whether they get treated, in other words, they get free lunch, and income would be related to the score that they get. Moreover, you can imagine that free lunch is actually provided to students who are in the low income groups. We don't just randomize and give free lunch to a bunch of random people. So most likely such an experiment or such a question would suffer from endogeneity. But given the regression context, you can add variables as a control variable to reduce or to mitigate the bias in the ATE. That's all, guys. Thank you. Bye-bye.